Paper 7, 6M BSc, Differential Equations, Session 2. Now in this session, we are going to learn about the necessary and sufficient condition for the total differential equations to exist. The theorem statements follows as it is. A necessary and sufficient condition for the total differential equations pdx plus qdy plus rdz is equal to 0 to be integrable is that it should satisfy this condition. The condition is as follows. P into dou q by dou z minus dou r by dou y plus q into dou r by dou x minus dou p by dou z plus r into dou p by dou y minus dou q by dou x should be equal to 0. Now let's start. First, the necessary condition. The necessary condition of the equation is P dx plus q dy plus r dz should be equal to 0. Let us consider this should be as equation 1. So this should be what? It should be integrable. This is our necessary condition that we know. So there exists a function f of x, y, z is equal to c. We already told that the function exists with two or more independent variables. So we have a function here f of x, y, z is equal to c. Let us consider this as equation 2. Now equation 2 is the total differential. The total differential of equation 2 can be written as df. And this is equal to what? df is equal to p dx plus q dy plus r dz. Now differentiating equation 2 totally, what do we get? df is equal to dou f by dou x into dx plus dou f by dou y into dy plus dou f by dou z into dz. This is equal to 0. Now we know that equation 2 is an integral of 1. So you can see here we have here p dx plus q dy plus r dz. Here we have dou f by dou x into dx in the same format plus q is dou f by dou y into dy. Dou f by dou z into dz is equal to 0. Therefore PQR, so if you compare that, PQR must be proportional to what? Dou f by dou x, dou f by dou y and dou f by dou z respectively. So let us write the proportionality like this. Dou f by dou x by P should be equal to dou f by dou y by Q should be equal to dou f by dou z by R. Let us consider it as some lambda, where lambda is a function of x, y and z. When I differentiate this, or when I take cross multiplication of each of the quantity with lambda, I am going to arrive like this. Dou f by dou x is equal to lambda times p. Let me take this as equation 3. Dou f by dou y is equal to lambda times q, equation 4. And dou f by dou z is equal to lambda times r. Let me take this as equation 5. Now consider equations 3 and 4. What does 3 and 4 gives? Which is equation 3 and 4? Here we know this is equation 3. Dou f by dou x is lambda p. This is equation 3. Dou f by dou y is equal to lambda q is our equation 4. Let us consider these two equations. So if I consider those two equations, I am able to write dou by dou y of lambda p. Or what do I know? I can write this as, we know what is lambda p. Lambda p is dou f by dou x. So dou by dou y of dou f by dou x. This is nothing but dou square f by dou y dou x. So this can be read, we know that dou square by f by dou y dou x is equal to dou square f by dou x dou y. So it gets interchanged, dou by dou x of dou f by dou y. But what do we know? Dou by dou x of what is f by? Dou f by dou y is, that is equation 4. That is your lambda q. So we started with dou by dou y of lambda p and we arrived with dou by dou x of lambda q. So now let us take lambda p, differentiation of lambda p. So what do we get? Lambda into dou p by dou y plus p into dou lambda by dou y. That is integrating with respect to lambda. This equation, that is dou by dou y of lambda p is equal to dou by dou x of lambda q. Differentiating this, product rule applying. That is equal to what? Lambda into dou q by dou x plus q into dou lambda by dou x. So what we have done from this step to this step. First we arrived at this, they both are equal, we got they both are equal. Now differentiating partially with respect to both, product rule, applying the product rule. Here we have solved and got it. So in the next step, let me take the lambda terms to the one side of the equation. I will get lambda into dou p by dou y minus lambda into dou q by dou x is equal to q dou lambda by dou x minus p dou lambda by dou y. Taking lambda common out, I am having dou p by dou y minus dou q by dou x is equal to, what is it? Q into dou lambda by dou x minus p into dou lambda by dou y. Let us consider this as equation 6. So we arrived at equation 6. Now similarly, if I try to take two equations like this, with p and q, next we can consider q and r, and we can arrive like this. Next r and p. So we will get three sets of equations. So when we similarly solve in the same pattern, we will arrive like this. Lambda into dou q by dou z minus dou r by dou y will be equal to r into dou lambda by dou y minus q into dou lambda by dou z. Take this as equation 7. Similarly, lambda into dou r by dou x minus dou p by dou z will be equal to p into dou lambda by dou z minus r into dou lambda by dou x as equation 8. Now here we have equation 6, 7, 8. Now we need to handle with only these three equations to arrive at that condition, integrability condition. So what you should do, multiply equation 6, 7, 8 by, here what is missing? P is there, Q is there, R is missing. So let us multiply by R. Here R, Q is there, P is missing by P, and here by Q respectively, and adding all this, what do you get? We get back our integrability condition, that is we get P into dou q by dou z minus dou r by dou y plus q into dou r by dou x minus dou p by dou z plus r into dou p by dou y minus dou q by dou x is equal to 0. We arrive at this condition, which is the condition of integrability. This is what we need to arrive at. See, let me tell you one note how to write this formula with the help of this note. How to arrive